record on the cloud. Okay. So let me go open R. Let me close these things completely. Close these things completely. Okay. So do you have R in your computer? You have R. How about you? Okay. So not you. So go there. Online people are seeing my screen, right?
Yes.
Okay, good. So are you seeing there are two things? And I first go there. Take a look at me. Actually, I'm going to make from next semester that once you will come to the class, give all the cell phone in here. Next year, from next semester. That will be the syllabus. So go to the Western Online, download these two things somewhere in your computer, or at least download this one, basic statistics R. Download this, okay? Go to the Western Online, download this. This is bonus materials I'm teaching you, okay? So go to the Western Online, download these things. I have downloaded these things, okay? Okay. Now go to the Google, and download this. Right, download R. Let us do the simple R, okay? Are you saying download R? Write it, and do with me what I'm doing. You have R already?
Yeah.
Everyone, you have R? Or everyone has R? You have R? Okay, go and do this, download R.
I don't have R.
Just go Google and write download R. Don't you see in Google or Microsoft Bing, like download R, then R project will come. Okay? So just click in there, download, then it will be downloaded, okay? Okay? So download this. And if you do this downloading, it will start download. So let me see, there is somewhere where I download R, and then run project somewhere. I can do mirror. And then if you go here, if you go there, download R for Windows, you will see there install R for the first time. It will be downloaded, okay? Okay, those people who already have R, go and open the R, okay? Open the R like this, so you will get this type of thing. Isabella and Tyler, do you have R in your computer?
Yes, I do.
How about Isabella? Are you installing, downloading? Now go to the file and open script. If you down save it somewhere.
Is this one, right?
Yeah, that one. Now this is the document. This is the R file.
Is the rest?
Yeah, open document.
Either it won't run or. If it
Yes,
doesn't
sir.
run,
Now go to the Windows. Style horizontally. So this is the code that I provided. This is the console where I will get the output. Okay. So if you not want to save, just go there. Okay, and it's here. Now if you write here 3 minus 1, hit enter. This is the console. Okay. So now you can do, yeah, so. So, 0, 3, 6. Command option L, then it is clear. So you are ready, right?
Okay.
Okay. So now go to the Western. Did you download that thing from Western Online?
Yeah.
Okay. So now I have this thing. See what I'm doing. Let me. It is recorded. Yeah, it is recorded. So now go to the file, open script, and then downloads and basic statistics by R. And then I want to do Windows and tile horizontally. Okay. Did you get similar thing like this horizontally or vertically? You got it? Windows,
Yeah.
tile horizontally or vertically. I can do vertically or I can do horizontally. So the two windows, one is editor, another one is console. We can set them side by side, okay? Or up and down. Did you get it? You're good? So you have these two windows, right? Tyler, are you okay? Are you with me, Tyler?
Yeah, I'm good.
How about Isabel? Are you with me what I did?
Yeah.
Okay, good. Now see, this document I also uploaded. Let me see, where is that document? Let me go and file, open, browse, downloads. Oh, I did not download it. But it is somewhere in there. Let me go there. This is the. You remember these things I did first day of the class? Okay. So I'm starting from the very beginning, like you can say spoon feeding. Okay. You like the word? Or you feel the insulted?
I love.
Okay, so see, subtract 1 from 2 in R or Python, right? So if I go there, see first one, if I run control R, then see 2 minus 1. In this case, it will be control R for Windows people, and for Mac people, command enter. Did you get this one?
Yeah.
Did you get this one? How about this, are you okay? You are struggling?
Yes.
Okay, could you help her little bit? She has a Windows computer, sorry, Mac computer. Okay. Did you get your first line of code running? Okay. Now second one is addition. So 3 addition 3 with the 5. Okay. So I bring my cursor in there, control R, 3 plus 5 equal to 8. Okay. And then I want to do the multiplication operation, which is 4 times 5 equal to 20. Control R for the Windows people, I got the 20. Okay. Then fourth one will be the division, 25 divided by 5. I got the 5. Are you seeing that? Are you getting that?
Yeah. I'm sorry.
Right? Is it working, right? So then if I want to do the like square of a number, which is equal to this, 3 to the power 2, which is equal to 9, you have to put it's called caret, right? Like we call also head, that is what we put it in there. And then exponentiation of a number 5, which we get 148. Exponentiation of a number can be obtained exp, and parenthesis you can put here 5. Okay. If I want it to be bigger font, like 20, then 20 like this. And then if I want to go window style horizontally, this is what. So now logarithm, 10 base logarithm equal to this. So 100 logarithm of 100 base is 10. That can be used like that way. Understand? And then logarithm of 100 when base is logarithm of 8 when base is 2. So base is 2. So that could be obtained like this way. Are you getting it? Are you with me?
I just want to ask questions like the log. How would it look like on paper? It's like one.
How does it look like in the graph?
This is not.
Okay.
He's asking like how would it look? There's a paper that's how the water. How that specific like what would be the base? What would be the
Okay, so
I'm good.
okay, so there is a definition. So log of 2 to the power x equal to m, right? This is the so definition 2 to the power n equal to x. That is the way. Okay. If you want to know more about these things, take a look. What does this means? Log 2 to the power log 2 to the power 8 equal to 3. Okay. Log 2 to the power 8 equal to 3. And then if you write, if in this definition, if you want to work in here, then 2 to the power 3. These 2 and m, 2 to the power 3 equal to 8. Understand? This is the definition of the log. This is the definition of the log. And then there is a, I don't know how many of you know the trigonometric function, maybe 2 or 3 of you know. Other people may not know how to compute the trigonometric sign. That is given on the problem number 8. Sine 45 equal to this, okay? Now I want to enter 30 data points. This is the way I entered the 30 data points, okay? 30 data points I entered in here. Now, you remember you asked me what does C means?
Yeah.
C means concatenate. C means concatenate. That means you are holding, you have a two babies, you are holding them like that. Understand? So I am holding all the 30 numbers in the bracket with the C stands for concatenate. But in the Python, we don't put C. We just put the double square bracket. Remember that, right? And then we have to put the parenthesis. So that's the way it is done. And then if I want to put the summary statistics, which you already know, summary statistics of the D1. So minimum, maximum, first quartile, third quartile, median and mean. Okay. So that is what we got. And then if I want to find individually mean, that is the way. If I want to find individually standard deviations, that is the standard deviation. If I want to find individually variance, that is the variance. If I want to find minimum, then D1 will give me the minimum. If I want to find the maximum, then D1 will give me the maximum. Clear? Minimum, maximum, all of this. Question?
No, I was just like, so that is a pointer, but very, right?
Any type of data or maybe any type of things you want to put, like you want them to be in a group, right? In that way, you have to put the concatenate. Okay? So, and then if I want to draw the histogram of this data, this is the histogram of the data, which you already know from the Python, right? And also basic statistics. HIST, histogram. If you want to have a box plot, that is the box plot. That is the box plot. If you want them together, that is the way you can want them together. This is the way you can want them together. Oh, where? Oh, I did not do this thing. So if you want them together, this is the way you can get them together. So let me explain what does this means, par. Okay? Try to understand what does this mean. Focus on the board. Par stands for parameter, okay? Par stands for what?
Right.
M, multiple, F, figure, MF, multiple figure, by row. That means one row and two columns, okay? Are you seeing one row and two columns? So this is the one row and two columns, okay? Two columns. So M means multiple, F means figure, row means row, and then you put the C. Again, you C and concatenate one and two, one row and two column. So these are the two figures for the quantitative variable. Now, if I want to do for the qualitative variable, are you okay? The thing is running to your computer. What happened to your computer?
We got killed.
What?
It died.
He died?
Yeah.
Computer died, okay. Okay, so now I want to use qualitative data. Okay, so this is the qualitative data that I put it in here. If you take a look at that, this is the qualitative data. What happened to that? Ooh. Okay, so I have to run that one again. So I have to run that one too. So now it is okay. Okay, qualitative data I have run. Now I want to see how many LT, how many AS, how many CC, how many AA, how many EU are in there. LT stands for Latino, AS stands for Asian, CC stands for Caucasians, AA for the African American, EU for the European. I created a synthetic data, fake data of the race variable. Now I want to find their frequency distribution, how many AA. So if I run this, there are 6 African American, 5 Asian, 9 Caucasian, 3 European, and 7 Latinos. How do we find it? By using the command, by using the code or command table. Okay, by using the command or code table. Now, for the qualitative data, we have two graphs. One is bar chart, another one is pie chart. For quantitative data, we have two graphs. One is box plot, another one is histogram. Okay. So bar chart and pie chart. Now, if I want to do bar chart, that is the bar chart. That is the bar chart. Okay. Are you seeing this is space is in there? So if I write a deviance of, then if I run it again, then see the figure is like that way. If I want to change a color of it, I can go there I can go there and put call equal to if I put here rate, and then if I enter it in there, so that is the rate. Okay. Color, and then pie chart as a default color, whatever type, if you run this, you will get this type of color. Okay. That is the pie chart. Okay, after pie chart, now I want to do them in 1 by 2 or 2 by 1. That means 2 row and 1 column. If I want to do this, then you will see this. So 2 row, 1 column. And then if you want to put here, like the, color equal to, if you put here, pink, then if you go there, right, Control R, you'll see the figure. So I have shown you very basic statistics by using this. Now I want to how to take a sample of size 10 from the data that I have created, right? So that D1 data has a 30 data points. I want to take a randomly a sample of size 10, which could be done by running this. Now, if I want to see this X, this is X and randomly. Okay. Now, if you go there again and run it, and then are you seeing this is different, right? First time I take a sample and put the sample in the X. So that those are 12, 20, 34, 33, 28, 25, 30, 26, 26, 26. Okay. And then if I again take the sample, then that is different because this is random sample. Clear, right? But if you want to take the same sample again and again, there is a trick. That trick known as the, I think, set.seed 100. I put this seed. Let me see whether it will work. Yeah. So now if I want to take a sample, sample D1, then 10. Now take a look at that. It is coming 34, right? Are you understanding? Now, if I want to do this again, I have to run this set.seed and then come there again. It is same. Are you seeing? Do you understand? Okay. Take a look at that. First line, I took a sample and then got 12, 20, 34, 33, 28, 25, 30, 26, 26, 26, right? First line. And then second line, I again take a sample that is different, right? That is different, right? But you want to take a sample, that sample should be same. Do you understand? In order to do that, you have to use the set.seed equal to 100. Understand? I put set.seed equal to 100, but you can put set.seed equal to 200 or 300 or 7,000, something like that. After setting that seed, whatever sample you will take, that sample will again come again and again if you use the same seed. Understand now? For example, take a look at that. I took a set.seed and take a sample it is 34, 27, 25 like this, right? And then I again replicate it, again I got the same. Are you seeing the last 4 lines? Last 6 line? Same, right? So how can we take the same sample? Set C. The number that you put, never forget that number. Understand? So that is why nowadays, when you do the research and publish your research work, you have to provide also the seed that you simulated the data, the simulation coming with a specific seed, then give that one. And the code, so that we will run, we will check whether those things is correct or not. Okay? So now I took a sample from there. After taking a sample, now you remember empirical rule. Within 1 standard deviation, what percentage? Within 2 standard deviation, what percentage? Within 3 standard deviation, what percentage? This is within 1 standard deviation from mean, which is equal to 68%, right? And that one is 2 standard deviation. Which is equal to 95%. Okay? Which is equal to 95%, right? And then last one would be that one. Within 3 standard deviation equal to 99.7%, right? Clear, right? 99.7%. Now what I will do, I will generate 100 observations, construct the histogram, and add the top middle point of each bar. Then I will see a curve like this. So that means this is normal. And then I will compute the 2 limit within 1 standard deviations, 2 limit within 2 standard deviations, 2 limits within 3 standard deviation, and want to see that rule follows or not. Are you understanding, right? This is called the empirical rule. Now let me go there and do it with clear. So R stands for random, norm stands for normal. I am generating 100 observations from randomly from a normal distributions. Let me tell you again. I am randomly generating 100 observations from normal distributions that has a mean of 10 and standard deviation of 2. Okay. So take a look at that. After generating this, I want to find the mean, which is equal to D3 equal to 10, approximately 10. Now, if I want to find the standard deviation, which is equal to 1.86 close to 2, right? Now, if I want to take a look at the histogram of D3, if I take a look at the histogram of D3 and then take a look, it looks like normal, right? Going like this way. So 50% be below the 10 and another 50% above the 10. It is the normal look like, right? Okay. So now within 1 standard deviations, those D3 data, let me put the D3 data. This is the D3 data. I will just compute one physically in order to convince you. Okay. So this is the data. Now, if I want to find that one, what is this value? I said this one will create 90% value, okay? So 6.51 to 13.95, I will get 90% of those value. Are you understanding? Are you understanding? Okay, let us do these things, okay? So we want to count physically in order to convince that our forefather gave the formula, that formula is absolutely right. They give a empirical rule formula and they said that if your data comes from a normal or Gaussian distributions, then within 2 standard deviations from mean, 95% of the data fall within, like under the bell-shaped curve and above the horizontal line. So let us do the computation. So short D3, and then let us do the computations now. 6.51. It starts in here, 6.51. Okay. 6.51 up until 13.95. 13 until in here. Are you seeing? 6.51, right? 6.55 is bigger than 6.51, right? So if you count all the way up until 13.67, that is below 13.95, right? So how many observations? 96. 96 observations lies between these two numbers. What was my claim? Empirical rule says what? 95%, right?
Yeah.
So out of 100, how many? 96. So this is approximately, right? Convinced? So nowadays it is easier to convince the students by running a quick simulation that empirical rule is true, and that is what you can see visually. You can observe, right? I simulated a data, I generated a data that has a mean of 10 and a standard deviation of 2 coming randomly from the normal distributions, and then I computed within 2 standard deviation range, which is 6.511657 and 13.959462. Now these 100 numbers I shorted ascending order. I want to see how many of them fall between these two numbers. I saw them, 96 of them fall between these two numbers. So our claim is approximately right, almost right. Our claim was 95%, but here 96%. Okay. Then similarly, if you want to do it for the last one, you will see all data, 100%, 99.7, right? 99.7 within 3 standard deviation. That means all 100% data falls in there. All 100% data falls in there. Are you okay understanding? Okay. So now next one is Chebyshev rule, right? Chebyshev rule. So if data does not follow normal distributions, instead data follow like this. If data has this type of distribution, skewed to the right or skewed to the left, so skewed to the left, this is skewed to the left, and this is skewed to the right. So if it is the income, there is more poor people than the rich people. If this is skewed to the right, so fewer people are poor, more people are rich, right? So this is the skewed to the left and skewed to the right. So now the question is, in a state of bell-shaped curve, if you have a curve that is skewed to the left and skewed to the right, what percentage of data falls under that curve and above the horizontal line? That rule is known as the Chebyshev rule, and it is 1 minus 1 over k square, and k is the number of standard deviations. And it was mathematically proved, and PhD was given, lot of PhD was given on that. That is called the Chebyshev rule. It was developed in Russia. the Russian mathematician, he developed Chebyshev rule. Okay, so at least 1 minus 1 over k square observations fall within k standard deviations. This is what I have done in this part. This is what I have done in this part. And now if you take the histogram, if you write the histogram of in here, you will see skewed to the right, east, D3. Are you seeing skewed to the right? Right? And that data is coming from the exponential distribution. Exponential distribution is skewed to the right. Okay. Now in these data that I have generated, if you construct within one standard deviation does not make sense, because 1 minus 1 over k square, k equal to 1, so 1 minus 1 equal to 0%. So that does not make sense. That within one standard deviation does not give any fruitful results or output. But if you do it 2 standard deviations, 3 standard deviations, then you will get at least that percentage of observations fall within that distributions. Okay. So after that, now you remember I created X and Y. Here is the X and Y, right? This is what X and Y I have created. Now I want to find the covariance of that. So covariance of that is this. Covariance means what? Joint variability, right? What is joint variability? When X increases, Y also increases. When X increases, also Y increases. Okay? X increases, Y increases. Okay? When X decreases, Y increases. Covariance could be positive, covariance could be negative, covariance could be 0. Okay? But covariance do not have any upper limit. Covariance does not have any upper limit. Covariance does not have any lower limit. So it could be very big number, it could be very small number or 0. So in order to overcome this difficulty, the statistician and mathematician, they develop correlation. Correlation has a lowest value -1 and correlation has the highest value +1. For example, if you go there, just write core, change it to the core, then it would be -1 to +1 any number. Okay. So correlation value -1 means perfectly correlated. One increase, another decrease, perfectly negatively correlated. Correlation -1 means. Correlation +1 means one increase, another one also increase perfectly. Okay. And then correlation 0.90 means highly positively correlated. Correlation -0.9 means highly negatively correlated. Okay. These are the basics of statistics by using R, which you have learned. In next class, we are going to learn advanced computing by using R, and then data analysis and data mining. I'm going to stop in here. I have 19 minutes. If you have question, you can ask me. Okay, I will upload this in the I will upload this in